Hello, everyone, and welcome to the A3 webinar series. Thanks for joining us for today's webinar, Offline Robot Programming and How It Can Impact Your Business. My name is Clarissa Carvalho, and I'm the Content Marketing Manager for the Association for Advancing Automation. I'll be serving as your moderator today. Attendees viewing this webinar are in listen-only mode, which means that you are muted. If you have questions during the webinar, please submit them in that questions panel at the right of your screen. We will try to address as many questions as we can at the end of the program. And if your question is not addressed during the webinar, the Robot Master team will respond via email. This webinar is being recorded, and a link with the recording will be emailed to you within the next 24 hours. I'd like to thank our exclusive sponsor of today's webinar. Robot Master is the leading CAD/CAM-based offline robot programming software, which provides quick and easy programming tools for multiple applications, saving time and money while maximizing return on investment. Robot Master delivers an unmatched offline programming capability for robots, easy programming of precise robot motion, and quick generation of trajectories of any size with minimal programmer intervention. Their strong background in CAD/CAM software has enabled them to bring a revolutionary approach to programming industrial robots. So thank you, Robot Master, for your sponsorship today. And I'd now like to introduce our presenter. Jim Beretta is President of Customer Attraction Industrial Marketing based out of London, Ontario. He's been an applications engineer in automation sales and in corporate marketing for ATS, Automation Tooling Systems, for most of his 16 years in the automation industry. For the last 11 years, Jim has been an independent marketing strategist focused on the automation, robotics, and advanced manufacturing industries. For A3 specifically, Jim has been a valuable resource helping plan and deliver webinar content to over 35,000 webinar attendees over the past 6 years. Jim is also the host of our A3 Robot Industry podcast. So thanks for being with us today, Jim, and I'll now hand this webinar over to you.
Thank you, Clarissa. And welcome again, everyone, to the webinar presentation. We have 4 expert panelists with deep experience in offline robot programming software and CAD/CAM, and I'm excited for the conversation. So we have 2 audience polls today. We have a couple of videos that kind of show what's going on with offline robot programming, or some of us will say during the presentation today, OLP. And then we'll have a question and answer with our experts at the end. So I'd like to now introduce our first panelist. Oh, first up, our first poll, sorry. So our first poll is, do you currently use robot offline programming software in your facility? So just click the radio button on the left of the screen. So you have 4 choices. Not at this time, so you're not a user of OLP. You may use a robot manufactured piece of software, or you may use a third-party software package, or maybe you're using several software systems. So if you could take a moment and just answer the radio button, that'll give us a kind of a peek at who we have on the call today. I always try to anticipate what we're going to see. I think we're going to anticipate a spread. Okay, so we have a lot of potential newbies on the presentation today. That's great. I'd like to then go ahead and we will introduce our experts today. Our first expert is John Martin. Actually, so this is this is John Martin. He's now in his 17th year at ARC Specialties in Houston. John serves as Vice President of Operations and oversees the project management, sales, service, and programming teams. Martin brings 17 years of experience in welding automation and 19 years of experience in industrial automation to the table, helping ARC manage product lines and create control systems programming for new machine development. Prior to ARC, Martin worked as an automation engineer for Goodyear in Topeka, Kansas, and spent time as an electrical engineer for General Packaging, where he implemented control systems and programming of vertical form, fill, and seal machines. Martin holds a bachelor's degree in electrical engineering from Kansas State University and is a member of AWS, an RIA certified expert level programmer, an ABB FANUC KUKA certified programmer, and code developer for various PLC, CNC, PNC, and PC control platforms. Next up is Keith Luce. He's a motion control programmer at ARC Specialties and a power user when it comes to OLP path and control programming. His specialties include RobotMaster, SolidWorks, Inventor, CATIA, CAD/CAM, and simulation. He's an expert in process development and manufacture of complex 3D components with wire arc additive manufacturing, 3D plasma cutting, deburr, and deflash, systems design integration, OLP programming, process development to RTP. Next up is Patrick Lazzaroni. Patrick has a master's degree in mechatronics, robotics, and automation engineering. He's worked in R&D and as an application engineer at Stovely, France, and as a customer support manager at Stovely, Japan. He's also been the Asia Pacific Technical Sales Support Coordinator in France, and now is the customer manager for Global Technical Sales Support. So we welcome you to the webinar. And last but not least, we have Corey John. Corey has studied at the University of Minnesota and started his professional career in 2007. After spending 10 years working in CAD/CAM software sales and support, Corey transitioned into robotic offline programming software in 2017, where he joined RobotMaster software team. Since then, he's been working with robot manufacturers, integrators, robot programmers to help make robot offline programming easier and available to the masses. So welcome, Corey, Patrick, Keith, and John. Corey, I'm going to kind of talk to you first and just give our audience kind of an example of offline robot programming. What is it and who's, so if you could just talk to that before we run a couple of videos.
Yeah, absolutely. So offline programming is something that a lot of people have a lot of experience in, maybe not on the robotic side, but specifically on the CAD/CAM side when it comes to machining. So roughly 20 years ago, you were programming your 3 or 5 axis machines, maybe at the controller, right? And from there, over the last 20 years, almost everybody has gone from teaching it at the controller to bringing it to a CAD/CAM environment, where you've got a process that everybody now accepts as a standard, where you have a CAD model, you create your path in your CAD model and a CAM software. From there, you may bring it through a simulation software, and once you got a path that you like, you bring it out to your 3 or 5 axis machine. Well, offline programming software for robotics is very, very similar, right? So where most people out there today are doing what you did 20 years ago at the CAM center, you'd go out to the robot, grab the controller, teach it point by point, which is an older way of doing it. Now we see a big move into this offline programming where you follow a very similar path that you did before. You've got a CAD model, use all that information that's on that CAD model to create a path. With that path, once you've got a path that you like, could be different processes, welding, could be cutting, trimming, whatever your process is. Once you got the paths that you like, you bring it through the simulation environment, make sure that you don't have any issues with your robot. And once you have that done, you can post it out to all the different robotic brands out there. So really, like I said, it allows you to very quickly and easily get an error-free program from the part all the way to finish.
Yes, thank you for that overview. It's great. Clarissa, if you can scroll to the next slide, and we're going to show a couple of videos, and if you can talk to these videos, Corey.
Yeah, absolutely. This is a part we worked with in partnership with Stovely at the FabTech show this year. But at the end of the day, what you're trying to do with any kind of offline programming is, being able to take that part or that simulation environment and match it up to the real world environment. So really having that digital twin between the two. And I believe there's one more video as well. Yeah, so here's another example with our Hypertherm torches, being able to do 3D plasma cutting here with RobotMaster. But once again, it's taking the process information, the path creation from the simulation environment and making sure that it matches up with the real world environment.
And that's the real thing, right? That's exactly your software in action. That's great. We'll move back to the question slide. And so this question is for John, Keith, and Patrick. But who is using offline robot programming?
Well, I'll start off on how we use it. We use it in 3 different aspects. We use it for the initial sale of a project. It's a quick, easy way to get a customer, I guess, up to speed on how our proposed system is going to satisfy their need and be a solution to the problem. Then we also use it during the design phase of machines. Mechanically, we need to know where to put the fixturing, how high the robot needs to be mounted, this kind of robot to part relationship. And so running that through Robot Master, you can actually see exactly where the robot reach is and where the tooling needs to be. So we'll take our 3D CAD models and put that into the system, into Robot Master, and have the actual design on the CAD or on the offline programming software. The other aspect is at the end, and this is where Keith comes into play most of the time, is on the actual programming of the parts. So I'll let Keith talk a little bit about that type of use.
So just about everything currently made is being designed in CAM software or CAD software. So we have a 3D model of what we're going to be making, and it's very nice to bring that model into software such as Robot Master and use it to actually create tool paths and to develop the process itself. So it's very efficient, especially relative to point-to-point programming at the machine.
Thanks for that, gentlemen. And Patrick, your thoughts on kind of who is using offline robot programming?
Well, we at Stubby Robotic work mostly with integrators and OEMs. So OLP, I will say, is particularly, but not exclusively, interesting for machine builder, for non-contact and contact material processing and dispensing. In this type of application, you have to handle huge trajectories that concretely correspond to many points to teach. And the traditional way to teach a point is directly teaching with the robot. But when you are talking about thousands of points, of course, it's often not possible. And this is where OLP is very interesting. And in most of the cases, well, in very few cases, if the trajectories are very simple, we can recommend to go for a direct teaching. But again, in most cases, we will recommend an OLP for this type of applications.
Thank you, Patrick. And I was going to ask the panel too, how is it used? Like, obviously, it's being used by a robot programmer instead of he's doing something else, but he's saving a lot of time. Like, how does he use it or she? It's used upstairs
I think I can answer this. So you typically have your machine running while you're creating a new program for a new part. This would be in a production environment. So the machine's running, making parts while you're developing the next generation of part program. So you actually create that offline based on the model, and you minimize the amount of time that you actually have to shut the machine down to actually test and release that to production. So these are used like in your CAD/CAM groups, your manufacturing engineering area, for part programming, and for us integrators, it's used throughout pretty much all phases of the project.
Right. So for one of our customers, they would purchase the software to use in their production environment. And like Keith said, it's the return on investment is there's a couple of reasons, but one of the biggest reasons for return on investment is that they don't have to shut that machine down from producing whatever product they want to produce. And that's what it needs to be doing majority of the time to pay for itself. So the robot software, or Robot Master software, paid by itself by keeping that machine running while you're developing new programs for other parts you want to put on that cell or next generation parts.
And to kind of further that, some of the newer, using robots and for 3D cutting, 3D machining, or 3D a lot of things, you can have a three-dimensional path or contour spline that it could take up to 500 points to actually track that path appropriately. So you can imagine teaching every single one of those points with a joystick, moving, teaching, takes you a considerable amount of time. Whereas with software such as Robot Master, it could take 5 minutes to actually create that path, tune it to where you want it, and move forward. So that to me is such a big payback.
Yeah, I fully agree with that. Usually we do recommend at Stubby to our integrators to embed a space or directly an industrial PC next to the machine, so that the part, well, the operators or the integrators himself can generate the part just next to the machine, looking at it and making sure that everything is okay. And then in our case, sometimes when there is not much product changeover, then it's only our integrator using a Robot Master or OLP And in some cases where we have many new product introduction and so on, it is actually the operator who will use Robot Master. So in this case, yes, we recommend to have a workspace with a visualization of the robot and of the workspace, so that the operators can directly create new trajectories from the PC next to the machine.
Thank you. We'll slide down to the next slide, Clarissa. Corey, you've been kind of quiet on this, on the return on investment conversation. And of course, what your thoughts on that?
Absolutely. So, you know, as a software sales manager, I work with both partners, integrators, and end users to help promote the software. And, you know, obviously, anytime you're purchasing something, the big thing is what am I going to get back for it? And I think John and Keith hit on it, and both Patrick did as well. You know, there's really two return on investments when you're looking at an offline programming software such as Robot Master. One is purely time, right? So you've got an engineer, a programmer, somebody who is sitting there. If they're doing it on a Teach Pendant, maybe it took, we've got several cases where something that took 40 hours before is done in 15 minutes. We've had some cases in the aerospace industry where it took 30-something days to hand program a very complex part, and we did it in about a day and a half. So one, you get the first time savings of just a burn rate of the engineer's time from their 40 hours down to 15, 20 minutes, 30 days to a day. And then the second return on investment, John hit on it very well, was you know, every time you take that robot down, you're losing money, right? You're not creating parts. Okay, so like I said, I always call it the dual return on investment, because like I said, you get the money savings from a person, but also the biggest one is you keep your robot in production for that time as well. So the ability to kind of bounce back and forth between the two.
No, that's a really good example. Thank you. I feel sometimes that offline robot programming software is something that isn't well known in the industry. Like it's to the point of digital twins. Is that your feeling as well, Corey?
Yeah, I mean, you know, I spent, you know, like I said previous, a lot of my time is in the education space. So working with customers and integrators to understand, you know, like we've talked about already today, you know, what is offline programming? When is it appropriate? What should I use it for? So I would say a lot of my time and the industry time and the A3 altogether is really based on the education of what it is.
And I agree with that. In our case, we have the same experience. I have the same experience where, well, we are dealing with a machine builder for material processing, for example, and often they are planning on teaching. So very often we have to introduce the idea of OLP, the concept, and explain what it is. Yes, it's not fully known yet, I will say at this point.
So there's lots of work to do for us.
Yeah, I think so.
And we'll go to the next question, Clarissa. Thank you. So John and Keith, I'm wondering, is there a typical size of programming like company that you have to be before offline robot programming software makes sense for you?
I don't think it's a particular size. It's it goes back to what Corey was saying, is the ROI on it. So it depends on how much you're utilizing that robot cell. I know Corey's going to say you're not too small ever, right?
Yeah, that's right. So when I talk about typical size of the company, really it doesn't matter. I mean, I've been on site at somebody's house who has a barn in the back with a robot that they're doing prototypes or, you know, things on Etsy, and they're trying to figure out, well, how do I make them faster and quicker, right? So if he has to hand teach program all these different, you know, one-offs, it would take forever, and the robot itself doesn't really pay for itself. So we've gone from anywhere with a guy with one robot in the back shed to, you know, $300 billion plus aerospace companies using the software. So, you know, really what we look for is, you know, are you doing production runs that you're going to do something the same thing over and over again for a year and a half or 2 years, and you're never going to teach it? You know, yes, we have benefits that we can help out with that, but really, you know, it comes back to that return on investment. When you're doing runs of 1, 5, 100, 1,000, right? Every time you take that robot down, you know, it's lost revenue. So, you know, it's more off of, like I said, it's, you know, small runs. The ability to quickly adapt to newer changes in the parts is really a big portion of what Robot Master brings to the table.
Yeah, I agree with
I'd
you.
like to throw something out there too. using a software like RobotMaster, it actually pulls the understanding of risk way forward in a project, way forward to design or development of a part. Because before you would wait pretty much to the end to see if it worked in a lot of ways. Where with RobotMaster, you're actually pulling based on the models and design. You can actually pull that forward and make changes to the design and the equipment of the process earlier, saving you a lot of money too. So there's an enormous potential for savings there.
Correct.
Yeah, you go back to the education of people using RobotMaster. We're still learning places that we could use it, and it's just this year is helping us dramatically and shifting our design to accommodate things that we found in RobotMaster.
Correct.
That's
And
very
one
good
of the
point.
One of the nice things with RobotMaster, we talk a lot about the end users, right? But really the partnership with the integrators like ARC Specialties. So, there may be, maybe, when we're dealing with an integrator, maybe they have only ever done welding cells, right? Where with the different tools that RobotMaster has, it allows them to maybe branch into areas they haven't done before. So maybe, they want to get into plasma cutting, or they want to get into polishing and grinding, and start taking on more opportunities. One, we can program them faster and easier. And with that, they can take on different business opportunities that they may not have had before.
So Corey, is that like you're a job shop and you're looking to quote a part, and you would use RobotMaster to de-risk that application?
Yep, correct. So you can do it in that way. And like I said, if you're an integrator who does maybe just focuses on one area, deburring or trimming or welding, it also allows you to expand that offering that your company may have.
Great, thank you everyone for that. We'll go to the next question, Clarissa. So I wanted to get, I'm not sure I understood this as well, but RobotMaster is robot agnostic. So it doesn't really matter which robot you're using. And we have a question about that, a poll later in the call today. What are some of the advantages to using an OLP that is robot agnostic? And maybe Patrick, you can maybe chat about that for a second.
Yeah, I'm not sure I want to answer that, but I will. Well,
I can start off if you want to, Patrick, because
no, it's okay.
like
I can start. But basically, using an OLP, you are, let's say, using a RobotMaster, you are using one language to create your trajectory, to create your path, and you will then export this trajectory to the real machine. With RobotMaster, for example, you can generate too many different robot manufacturer programming language. So it is the case for the VAL3 from Stobly, and therefore you could very well use the same interface you are familiar with, the operators are familiar with different brands of robots.
Correct.
Even though I recommend Stobly, of course.
And we do love the Stobly brand as well. Yeah, as Patrick said, it gives you the ability that your users don't have to learn several different softwares to be able to get their projects done. It gives you the ability to program your part, bring it to that simulation environment, and maybe on your shop floor you have 4 different brands, right? Be able to program it for one brand. Maybe that robot needs to go down for servicing, or maybe it needs to be used for a different product. Very easily, you can take that program that you've already created for, let's say, a FANUC robot, and you want to move it to your Stobly robot. Very quickly, all you have to do is change out the cell, maybe fix any issues that have changed with the kinematics of the robot changing in the new cell, and then just be able to post it out right to the Stobly code. So the ability to bounce back and forth their different robot brands and being able to program up to 12 of the major manufacturers in the United States is a big plus for the RobotMaster software.
For us as an OEM, it has to do with robot lead times as well. If we have a product line that all of a sudden that robot is 12 to 15 weeks to get, we have the option to go to a different manufacturer that may be stock in Michigan or something like that. So it does give us a little bit more versatility.
Really allows you to master one set of software and apply it to a multitude of robots. It simplifies things in a lot of ways.
Right, because I think all the robot manufacturers have their own programming software, but then you're kind of locked into the way their way of doing things, and so you got to relearn that for every manufacturer. a product like RobotMaster, you're learning just that one time, and it applies to robot manufacturers.
And for some people who don't have a lot of experience in robotics, the reason why it's important to be robot agnostic is, it's not like G-code in the CAM side, right, where every manufacturer has essentially the same standard of G-code. In robotics, every manufacturer has a different set of language that they read in. So KUKA, Stabile, ABB, all the different brands out there post to a different language. So really on the RobotMaster side, the user really doesn't see that. When they bring in their robot, when they post out, it's going to post out to the correct language for that specific robot.
Those are some great points. Thanks, panel. And I liked Keith's point about, you're not learning 5 different software programs, which essentially do the same thing as just one agnostic program. So we'll go down to the next question, Clarissa. So what are some of those key considerations when choosing offline robot programming software? Corey, we can start with you for this one.
Yeah, this might be a good one for John and Keith and Patrick as well. But when you look at choosing an offline programming software, one, you want to make sure it's for the application you're doing. So if you're doing any kind of manufacturing processes, RobotMaster is a good fit there. You need to see, are you doing, production runs that are going to run for 2 years, or are you looking at, small batch runs? What is the time frame you're trying to get things done in? So there are several considerations that you should look into, but those are just some of them.
That's good points. I guess the main thing that we found in a few projects we've worked on is that, and it's mostly with the plasma cutting, the type of term plasma cutting, 3D plasma cutting cells, is there's really no path for you to program a cut on. If you have this part in front of you that is 3-dimensional in shape and you need to cut around at different angles and different bevels, there's not like it's a joint, a welding joint that you have point A, point B. You can teach it. There's really no way to do it in, I guess, the classic type of teaching platform. At least it would take you forever to do. So I know Keith has some experience with this.
Yeah, for example, we work with a customer who actually had a 3D CAD model 2 years before they actually made their first part, and it's a complex 3D part. And just like John said, there was no way you can program it when you had the part in front of you, because you're creating somewhat abstract lines on the part as cuts. So we did a proof of concept and machine design before they ever actually made the part, which helped their lead time and ours.
And Keith, while we've got you on that task, how hard is it to learn offline robot programming?
I would say it's not difficult. I think understanding, as a precursor, understanding how at least basics of robots is important. But after that, RobotMaster makes it really easy, and in terms of creating paths and exporting.
Yeah, I don't think it's something you're going to pick up in a day.
No,
Keith's still learning by using it. That's the thing, is you've got to learn a little bit to be dangerous, and then you continually being an expert at it.
So currently still learning by immersion.
Patrick, I want to switch the question around a little bit and kind of ask you a question specific to robot, because we talked about this in our warm-up call. How important is robot accuracy now? Because we're talking a lot about offline programming. Can you talk a little bit about the importance of robot accuracy?
Yes, the robot accuracy is very important. And actually, there is a key performance to take into account, a performance information that you will usually not find in the sales pamphlet, so you have to be careful about that. It is the absolute precision of the robot. So it means the ability of the robot to move, to match the simulated trajectory in the real world. So the ability to really match the virtual trajectory with the real trajectory. So it is basically the ability of the robot to move accurately to a coordinate in space without manual teaching. And this is very important. And this is called absolute accuracy. So you need that so that you don't have to readjust the robot trajectory after having exported the trajectory to the robot. This is very important. And then, of course, you have other performance characteristics such as path accuracy, but this is particularly important for the quality of the process itself, I would say, more than the OLP. Then one more point, I'm not sure we mentioned it, but So when choosing an offline programming software, you have to make sure that this offline programming software is able to export to the language of the robot, as I mentioned before. So this is, depending on the choice of the robot, you must make sure that this OLP is able to export in the right format so that the robot can use it.
Correct.
That's great.
Another thing about accuracy, if you would, Jim, is the accuracy is also to the robot, but it's also to the tooling, to the fixturing, where the part is in space. Because that's a lot of the customer questions from us is how do you match up real world to the simulated world? So first, you have to have a good model of the fixturing of the cell where the part is in space. And then you have to have the path accuracy of the robot. And after that, you have to have some means of accounting for part deflection, part changes, and you can do a touch working type touch sensing to figure out exactly where the part's at, or a laser touch sensing or mapping with some other secondary laser. So there's other techniques that need to be put into place to match that precision and accuracy within the parts.
That's a very good point, yes, because it's really about a chain of tolerances that will define the quality of the final installation. And as John mentioned before, I believe it was John, it has to be taken under account at the beginning of the project, because integrating an OLP, as mentioned, requires a special setup in order to really take advantage of the OLP.
Yeah, and it's important to, you know, if you have an integrator and you have a good relationship with them, when you're looking into an offline programming software, is really getting the three of us all together at once. So this way you can work with people like ARC Specialties here to see, okay, hey, you know, there's going to be some warpage in this part. How do I make up for it? Is it, you know, okay, well, we can take the nominal path out of Robot Master, and with that laser touch sensing, we can add, you know, some calibration into there. So, you know, really having not only the relationship with with us at Hypertherm and the Robot Master product, but also bringing everybody together, your integrator, like I said, like ARC Specialties, to be able to kind of bring everything full circle.
Some good points here. Thank you, everyone. We'll pop down to the next question. So I think this is always the best part, is to talk about some of those use cases that are out there that you're either working on as an integrator or as an end customer. So John, why don't we start with you on that?
Sure. Yeah, we have a project we're working on now that is it's a robot, two robots on tracks, and they are cutting a frame, and so it's about 10-foot lengths, so it's a pretty large envelope, and all of that was programmed by Keith here using Robot Master. So I'll let him talk a little bit more about that application and a couple others. So that project calls for cutting very precise holes in specific orientations that almost none of them are normal to the robot axis, and they're not all the same size. So instead of actually trying to teach a circle, creating a perfect virtual circle mathematically with Robot Master is very important, and then placing that circle in space relative to where it needs to be is really not something that's easily done on the floor. You know, if you were out there using a digital level and other stuff, I think you may be able to get close, but I don't think you'll ever get as close as numerically creating the model. So that's one application, and I'll back up to the other application for the complex 3D plasma cut. You know, that project had for one part program, it had close to 10,000 lines of code that runs through the robot. It makes the robot move from point to point, turns the arc on and off, moves home, moves away from home, and you know, that was a process development, you know, and actually what remains out there now in production is probably 4 near complete revisions away from where we started. So I'll just say that changing it, learning and updating it based on what the customer needs and what's best for a very robust process. Right, because in the manufacturing of something new, the customer is going to change the part on you several times.
Yes.
So having that offline ability, just throw in the new CAD, update the program.
And,
very.
The customer was amazed when they asked me to add 4 holes in these abstract locations and create another abstract slot, another location, and 2 hours later it was in production. was pretty impressive to them.
Nice. Corey, do you have a story for us as well on an application?
Absolutely. So we've got a company out of California who was programming lip skin. Well, first it started out with hand polishing and sanding of lip skins for aircraft engines. So they were sitting there going back and forth with, which is labor intensive to be able to do that. Then they moved into the automation of that and doing it by trying to teach these complex services with their Teach pendant. And then they moved into the Robot Master software. So we do have a case study up on our website. You can look under success stories and read all about it. But essentially, they were able to save a ton of time by doing it with the Robot Master. But the other big benefits that they saw was one, it didn't take, with the Robot Master software, it allowed them to have better part quality. So the quality came out better. The products all came out very, very similar versus if you're doing it by hand, they end up not matching as well. And then finally, it really helped their employees not have to be in the room while they're polishing and getting that dust, in their lungs. So it was a kind of a safety issue. So with the Robot Master software, they're able to fix a lot of those issues.
That's great, thank you. We'll slide down to the next question, Clarissa. So this, I guess, is kind of this one question about Robot Master that, I find it very interesting and very intuitive, but what are some of those things that make Robot Master software unique?
Yeah, absolutely. And we've got a little video here coming up as well. But, Robot Master has several distinct value propositions when it comes to the software. One, we've talked about it quite a bit, the ability to be robot agnostic. So if you have several robots brands on your shop floor, you have the ability to be able to program all of them with one software, only having to know one software. So that's one. And maybe you can go into the next slide, Carissa. So here's just a quick user interface video here. So another big benefit of Robot Master is the ability to pre-process your program. So once you have a path and you bring it into your robotic simulation side, it's going to tell you right off the bat, am I good to go or not? So you can see on the left-hand side here, we've got several green circles telling me all those paths are good to go, but we had one that was red telling me I have a kinematic issue. On this kinematic issue, it was a reach issue. So we have tools like Orientation Helper to say, hey, what if I lock my my head into this orientation? What would happen? So it tells you right away, yep, if I was to do this, it's going to create a good path. Kinematically, there's no collisions. And when I say robotic issues, we're talking about singularities, joint limits, collisions, auto reaches, wrist flips. So the ability to move and create and fix these errors does make a Robot Master kind of stand out. And there's other tools in here that we haven't shown here. So this Orientation Helper allows you to lock into one specific orientation of that tool. But we have tools to help dynamically change as the tool goes around the part too as well.
No, that's great. Those are some good answers. Just wondering if Keith or John, if you have any points on what makes the Robot Master software kind of unique for your customers and for yourselves?
I would like to throw out there, there's a tool within the system called optimization. And what it does is it takes the overall path and then it does lots of calculations and it overlays these colored blobs and a path line. And it tells you if the line's red, it won't actually work. And it kind of gives you a good indication as to where you need to move that line. And that line actually is relative to the tool axis. And so when you're doing some very, very tight or very complex shapes, that was really amazing when I first started using it for allowing you to make something that you almost didn't think was going to work actually do exactly what you wanted it to do.
Again, taking the risk out of it and experimenting and making all kinds of mistakes. So this goes to the ROI of saving hundreds of hours possibly on an application.
Yep.
And I think if anybody's seen some of the error messages on some of the robots when you're trying to teach by hand, it's not nowhere near as helpful.
Corey, I was going to get you to explain what a kinematic error is, but I think you did. But just in case there's some people on the call today going, what is a kinematic error? Can you explain?
Yeah, really. So like I said, it comes down to, robotic errors that happen when you're out on the floor. So it could be an out of reach, right? So the robot can't physically reach out to that position. It could be a singularity that comes up with a mathematical error where two joints are aligned. And they're very pesky. I'm guessing Keith has run into some of those. And trying to fix those can be very, very tricky. It could be a wrist flip or an over travel. So when a robot gets out of position and needs to unwind a joint, that causes an issue and creates problems within the path. Collisions, obviously, are you going to, gouge your tool? Are you going to run the robot into the wall? Different things like that. So like I said, being able to see right off the bat what your issue is, where it's at, and then have the tools to help easily fix that is a huge portion of offline programming. And that's what RobotMaster brings to the table.
Yeah, I fully agree with that. And I will say, even beyond this, it's also basically a robot is like a human arm. And when you write or when you are doing a job, you want to be in your best position. So it's really one thing that RobotMaster allows to do is we have seen in the video adjusting the RZ position because we have a freedom of liberty here for laser cutting. So we can adjust this position also to set the robot in the most comfortable position. And this will give the best performance as well.
Nice, thank you. Okay, so I think one last question for you, Corey, that you've just released. You've done some major releases to the RobotMaster software. What's contained in some of those from a high level in the latest release?
Yeah, absolutely. So RobotMaster V7 was a project that we spent over 7 years developing, retaking what we've already been successful with, and started from code line 1 and rewrote the entire software package to get ready for the next evolution and revolution of robotic programming that we're seeing here today. So about two and a half years ago, we released 7.0. We're on 7.5. We released last month, but we continue to add in different modules to help all of our customers in the different applications. So we started out with contouring, where you can do cutting and deburring and dispensing, something following a line. We went to welding. We've released a servicing module, a cell creator. So it's really creating a full offline programming suite, like we've said, to create paths quicker, easier, and get those paths to the robot and get them running.
Thank you for that. And we'll go to our next slide. So we are now open for questions. So Clarissa, I'll ask if you don't mind opening the questions.
Certainly. All right, we've got a ton of questions coming in, so I'm just going to and then Jim, you can filter to each panelist. So how do you know when you are ready for OLP?
Yeah, John and Keith, how do you know when you're ready for OLP? Or is that the second thing you should buy after you bought a robot?
Yeah, when you have a robot, for me, that would be the second thing, but I'm a little, I think you got to look at your production rates out of it. So if you have this cell running 24 hours a day, you most definitely need to move into that in order to keep production up on changing of your parts you're making. So I think if you're making the exact same thing and that's all you're making, I think you may think about it. But if you're gonna do multiple parts, you're gonna have revisions and changes, then I think it does make sense.
It seems that's the life we're leading right now is high mix and medium to small volumes. In some cases, you're fortunate if you get this high volume, low mix, of course. Corey, is that what you're finding out there too?
Yeah, like you said, that high mix, low volume is really a big sweet spot for the RobotMaster software. If you think about it, you're having to go in and either update a path or change it on the fly. It takes quite a bit of time to, one, make the adjustment, two, take your robot out of production. So it hits on a lot of the things that we've talked about earlier.
Great, thank you. What's the next question?
What are some of the user challenges with integrating OLP?
Guys, John, I think I'm going to ask you what are some of those challenges?
Yeah, the biggest challenge is getting the software or the cartoon world, to match up with real life. It's a challenge many times.
So you would start with the models that make up the cell and the part you're going to work on and the tooling, and the robot are typically available through the Robot Master website.
Right. So if you have custom tooling though, you have to have the model of that tooling to be able to use the software. So it has to be working with the OEM of the equipment to get those models to be able to efficiently and effectively use the software.
And you then set up all those models in a station, and then you have a stable station that you can set up to create part programs or functional programs. But
So tell me a little bit about how to match up the part to the software user frames.
Okay, so
that's the real world.
So I would bring a model in of the cell that the robot sits in, and I would actually set its origin appropriately to where the robot's gonna, when I import the robot, it goes in the right position. Then I would import the robot, and I would export that as a cell, and then I would open up another station, and I would import a 3D model representing the tool, or I could create a 3D model with maybe a pointer if that's all I have. And then I actually set that tool up in much the same way where the origin is set up appropriately and the tool or the station is in the correct position. And then I would bring that into a programming station. I bring the cell and the tool into the programming station. One of the things that you have to really be careful of is when you actually create the tool that you would manually set up on the machine, it has to match in its orientation plus or minus a degree or 2 degrees, and it has to be dead on in terms of your translation. If it's not, then you may run into some problems. Say you're tracking a wall, and in Robot Master it says you've got clearance, but on the real world your tool is rotated 30 degrees. Well, you're going to have a collision. Both of those things have to match. Once you do that, it's really quick to create a new program with that station that's proven, that's refined to the machine. And like we were saying earlier, post that to code. You may do some edits. I do edits in Notepad++, and then I save it to a thumb drive, load it to the machine, and test it, increase speed, release to production.
Yeah, I fully agree with that. And as mentioned before, when we were talking about the robot precision, it's really a chain of tolerance. So it means depending on the level of performance we want to achieve, we have to be very careful at every location where we could lose precision. So the G positioning, the tool calibration, the robot performance itself. We have to look at all this little potential loss of precision in advance in the design phase to really reduce the overall error. And I think this is, in my opinion, this is one of the biggest challenges.
Yeah, and this brings me back to the point earlier in the presentation. Having a good relationship with your integrator and the people who help build your cells and with Robot Master is really going to help make this go a lot easier. Because it really comes down to, you have your simulation environment, right? But you need that to match up the real world as much as possible, both in the CAD model and then grabbing that calibrated data that Keith and John had talked about. So knowing where your center of your tool is, your tool center point, where your part is in your simulation space and into the real world with your calibrated user frame. So like I said, a lot of people want to and try to bring Robot Master in on their own, but really, they've had success with that. But really, having a partnership with your integrator is very important.
And Corey, just a sidebar question. So an integrator is a company that resells Robot Master software, right? They're a distributor.
It could, some do, some do not. We'd love for more people, more integrators to join the Robot Master partnership program. But integrator is the person who is creating the cell. Could be the person designing it, doing your first part run. So a lot of the times, people come to us. They have a cell that ran its cycle with the part that they had programmed, and now they want to bring a new one on there, simpler and easier. They'll call us to use Robot Master. And with us, we'll go back and work with their original integrator to help make it match up as best we can and make sure their cell itself is running properly.
I think this is a related question, but are there any helpful techniques that could help with part alignment in robot cells?
I think that's probably one for Keith and John.
So So fixture design is very important. You want your part to go into the fixture and be seated relative to how it was designed the same every time. And then what you're trying to do is you're trying to isolate variance in everything. So isolate variance in part where it's actually sat, then isolate or correct for part variance based on its design tolerance. So John mentioned earlier that we try to use aligned or fixtures that force the part into a specific position every time as it's loaded, and we use lasers to find a feature or multiple features to correct for part variance, or we've used touch probes in a lot of welding applications, and I think we've used cameras or vision systems and even other applications to say I have a circle that I have to cut 2 circles to the side of. So I want to find that circle and set up my user frame relative to that circle to cut those other 2 circles. So that's like a vision application. So I guess to really simplify it, eliminate the variance and then verify through probing.
Right. Fixturing is the key to successful automation. So you have to have rigid, consistent fixturing. You get that, and then your laser or your touch probes are used for minute changes in either the part deformation or the manufacturing upstream to that part.
Because the parts you're working on is always going to have design intolerances as well, and they may not be in your favor.
Thank you. Okay, so we talked a lot about like path programming. Does OLP offer any utility for programming I/O and logic aspects of applications?
John, that could be for you.
Maybe Corey. I don't know.
So I'll let Corey answer this, but I typically use it for kinematics, in other words, creating and exporting paths, but not necessarily for logic.
Yeah, you can, with if you have any experience with, like I said, the 5-axis machining, there's all these different callouts that you can do or macro programs. So RobotMaster has the ability to create in its post-processor, special commands or IOs that you want have happen inside the software. So it can push it out there. It just depends on how you want to program your robot. So you can either do it at the pendant, at the machine, or in the software.
So I have quite a bit of experience exporting the text file that would come out of the post processor and then updating it directly with like a text editor, adding a lot of those commands that I need to, or calls to functions, or calls to IO, or stuff like that. But like Corey said, you can add a lot of stuff inside the station.
There are particular instructions of the robotic language that we may want to use, I think, in RobotMaster and OLPs in general. And personally, we never had, we always found a way to integrate these specificities. In Stobly programming, we have some specificities as well. For example, we want to trigger the IOs, of course, but we want to trigger them during the pass and not at the beginning of the path. So even for this kind of modification, we find in RobotMaster a way to customize the post process in order to match these requirements. So this has never been a blocking point, at least for us at Stobly.
Yeah, and I think to carry that forward, I personally have never had a post processor customized to a specific application, but I'm understanding that's common.
Yep.
Thank you. I am just scrolling through all these questions. As a reminder, if we don't get to your question, the RobotMaster team will answer them via email, but let's see if we can get at least 2 more in. So we mentioned how hard it is to locate the robot on complex or abstract curves. Can robot tool paths be predefined in the CAD model?
So I would say yes and no. Yes, in that if you create a cut edge or a surface or an edge, that edge in RobotMaster is directly selectable, and it will allow you to create a path along that. And from there, you have, I think it's going to come in as like, let's say, normal to the local surface that you're on. But you can actually change the normal to actually just about whatever you want. But in terms of creating it in the CAM or CAD, I think you create the feature in the CAD, and in Robot Master, you're really selecting that feature and then saying, I want a path on that feature.
Right. So it does tool paths on the feature. The air moves are all pre-done, right?
So
The CAD model.
No, the air moves are, go ahead.
I was just going to say that, this really comes into play a lot in welding. A lot of people will design in their CAD package where the welds are, how long they want the welds to be, and whatnot. So we can actually use that information that's put on the CAD model, the specific locations, the size of the welds, to be able to do that. So we're using the features or something that was drawn into the CAD model to be able to do that. And like John and Keith are saying, most of the time, they're not creating a path inside the CAD model. It's a feature, a circle, an edge, something that we're going to drive and create the paths off of that CAD surface or the model.
There's lots of options for how do you want to handle that in terms of, do you want to teach a path on an edge? Do you want a sword path that matches a whole wall relative to some other normal or some other access? But it's feature based. In other words, you pick the feature that you want to create a path on. And but I've never used the welding side of it, so I can't really speak to that.
Thank you. This might be related, but how do you use offline robot programming when having a wide variety of differently shaped parts that you have to weld together? There's a follow-up question. What is your opinion on the programming time for engineers in this case?
Programming time, how much time it would take to actually create a program? Yeah, that's going to vary widely based on the part and what you're starting with. If you're starting with a bunch of components, you need to assemble those components in the nominal structure and then start working from there. But once you assemble them in a nominal structure and you've identified where the welds are going to be, Robot Master is amazing at letting you know, can you actually get there? Can you get there in an orientation that actually is weldable? So that's a benefit of doing it that way to begin with. But yes, you're looking at a complex assembly that's welded together. Robot Master is probably the best way to look at that.
It's definitely faster than if you did it by hand.
Yeah, absolutely.
And having a high mix like that,
I think John hit on it too earlier. Is having a good, good fixture, right? So having all these shape parts put into a good fixture so you know where they're at. I know we had a customer who was creating these big underbodies for like a skid steer company, and it was taking them, I think, 46 hours to hand program, and it was something we did in like 25 minutes. But once again, they had the assembly, the CAD file, and the fixtures all put in there, so you can drive the pass right off of that. So instead of having to try to dive in there by hand and do it, we're able to see right off the bat, am I going to be able to do it or not, and how to do it.
Thank you very much, gentlemen, for all your answers. We had so many other questions to get answered, but I will send you all the questions and you can respond to our attendees directly. So thank you again for your time.
Yes, absolutely.
Thank you.
Thank you.
So Corey, I'll just ask, like, if I've got a robot and I need to dive into this a little bit more and understand, do I need offline robot programming? What are kind of the next steps if somebody's at home and they're wondering what to do?
Absolutely. There's several different resources you can go to. First off, you can reach out to me directly. My contact information was in the PowerPoint. So you can reach out to me directly via email or phone call. You can always check out our website at robotmaster.com. We also have the ability to look at different customer success stories, applications that we've run into, and things that we've done there. You can request a live demonstration. The website's here, or you can also email our generic email address at info@robotmaster.com.
Great, thank you for that. And we have one last poll.
We do.
Excellent. So just like before, if you can answer the radio button, how many different robot brands that you have in your facility? So maybe you don't have any robots, that's great. You have none. Maybe you just have Stoigli robots, or FANUC robots, or if you have 2 to 3 robot brands or 3 or 4 robot brands, and we'd love to share that information with you and find out what you have. Again, a good spread. So there are a bunch of people who also have 3 or 4 robot brands. So that's very, very interesting. Thank you for that, everyone. So Clarissa, I'll hand it back to you.
Thank you very much. Please join us this upcoming Tuesday for our next webinar, Putting Motion Control to Work in Your Production. This webinar is part of our Automate Preview series, which covers key technologies in automation. We'll be hosting a panel of experts to discuss the latest updates on motion control and how to better deploy these technologies in your operations. So you can register for free at automate.org. I would once again like to thank RobotMaster for their sponsorship and to all of our panelists today. If you have any questions about A3 or today's webinar, please reach out to either RobotMaster or myself via the contact information you see on the screen. As a reminder, this webinar has been recorded and an email with a link to the recording will be sent to you in the next 24 hours. So thank you again to Jim for moderating, and John and Keith and Patrick and Corey for sharing all your information and your expertise. And all of our listeners for your support. Stay safe and healthy and have a wonderful rest of your day. Thank you.
Thank you, guys.
Thank you.